In this video, we're continuing to explore unit rates, and it's summarizing everything we've really done with unit rates. This video is a review in some sense, but connecting tables, graphs, and equations. In the lesson summary, you see it says unit rate can be located in tables, graphs, and equations. In a table, the unit rate is the value of the first quantity when the second quantity is 1. So for instance, if you're working in a table and you see its relationship between 3 and $40.50, you would bring it to 1, and I think that would be $13.50. So that's what a unit rate is in a table. In a graph, the unit rate is the value of r at the point 1 comma r. So it's looking at what is the y value when the x value is at 1. And however high this point will be, that will give you the ordered pair 1 comma something, which is the same thing as in the table. It would just be over here. And in an equation, the unit rate is the constant number in the equation. For example, the unit rate in r equals 3b is 3. That 3 is that unit rate. So what it's saying is if b is 1 in here, then r would be 3. So it's that number that's keeping everything constant. And then you could plot that as well, just like you would in a table. Putting this into practice and just a couple of problems. The first one says Claire and Kate are entering a cup stacking contest. Both girls have the same strategy. Stack the cups at a constant rate so they do not slow down at the end of the race. While practicing, they keep track of their progress, which is shown below. We see that Claire is stacking cups, and the points are given. We see that in 3 seconds, she can stack 15 cups. And so on. 6:30, 9:45. All of these points represent ordered pairs that can be plotted into a table. So if we were making a table, those would be our 3 points. Kate, however, C equals 4t, where t represents the amount of time in seconds, and C represents the number of stacked cups. So if we were to plot this, t is the number of seconds. So if we're just going to organize this information in a table, we would have seconds, so you could do it in a t-chart too, seconds and cups. And the cups equal 4 times the seconds. So if the seconds are 1, the cups is 4, and so on. At what rate does each girl stack her cups during the practice session? So if we look down here, we would say, well, Kate, we just found, she stacks 4 cups per second. And anytime we're talking about unit rate, we need those labels. When we look at Claire, we know she stacks 3 cups, and if we're going to put hers in a table, and we're doing seconds and cups, we can see that in 3 seconds she stacks 15 cups. So if we want to make that a unit rate, we need to get it to 1 cup, which would be 5. So Claire would be 5 cups per second. And you can see as well that we would have a point right there. Oops. And that's what it means on a graph, trying to find that unit rate, looking at where the line crosses at 1, because it will continue on that perfect slope. So it crosses 1, second corresponds to 5 stacked cups. That second question down here, Kate notices that she is not stacking her cups fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? Well, right now, C, which represents the number of cups, cups equals 4 times the seconds. Well, we need to get it to be more than 5 cups per second, which is actually really impressive. If you stop and think about that, 5 cups per second. But we would need to get the cups, let's say 6T. And that would be something you'd graph too. If a problem on the homework says, okay, turn that into a graph, you would have seconds would be 1 second, and then 1, 2, 3, 4, 5, 6. And let's say this was 6, you would plot that out. And you would continue. And you would see her slope, if we were to put it on the same graph, and I'm going to do Kate now. Kate would be 6, 2 would be 12, 3 would be 18, and you could see her line would slowly take a steeper slope if we were plotting Kate's. The second problem we'll go through pretty quickly. Emilio wants to buy a new motorcycle. He wants to compare the gas efficiency for each motorcycle before he makes a purchase. The dealerships presented the data below. The sports motorcycle, and you can see it shows number of gallons of gas and 5, 10, 15, 20, and the number of miles you can go. And on the right side we have a leisure motorcycle, and it's showing the same information in the table. It says which motorcycle is more gas efficient and by how much. To answer this question, once again, we're going to have to get it to unit rates. So the unit rate for this, we'd have to figure out for 1 gallon, how many miles would it go? And to figure that out, we have to divide by 5. And I'm just going to show this on the calculator. 287.5. Oh, I hit the wrong button here. 287.5 divided by 5 is 57.5. So we can say the sports motorcycle gets 57.5 miles per gallon. So that's per 1 gallon. Here we can see that this is the leisure motorcycle. 2 gallons is getting us 210 miles. So at that rate, 1, which would be right here, we could assume would be 55. So we can say this is getting 55 miles per gallon. So, which is more efficient? Well, the sports motorcycle is, because you are getting 2.5 more miles per gallon. That's an example how you can use different types of data to come up with unit rates and answer questions.